Hello, Algebra 1. Today we're going to be looking at section 9.6, where we're going to be learning our final method of solving quadratic equations using what we call the quadratic formula. Now, this name is appropriate because the quadratic formula is used to solve quadratic equations. When you look at the quadratic formula, the first thing you want to note is that you can use the quadratic formula when you're trying to solve an equation of this form, where if you notice on the left side, it's in standard position, which means you put the highest power of the variable first, right? So here we have x squared, and then after x squared, we have just the x term, and then we have the constant. And also notice that you have a 0 on the other side, right? So anytime you want to solve an equation of this form, what you're going to do is you're going to identify the a, b, and c values, and then you're going to plug it into this formula here. It might seem very intimidating at first, but after we do a couple of examples, hopefully you'll kind of see that this isn't going to be that bad, but you have to memorize this formula, okay? And so let's look at this box right here, right? How to solve using the quadratic formula. So first, you're going to write the quadratic equation in standard form, which means, again, you want to put the highest part of the variable first, and you want to make sure you have a 0 on the other side. The next thing you want to do is identify a, b, and c. A is just a number that's in front of the x squared, right? The coefficient of x squared. B is the number that's in front of the x. And then c is your constant term, okay? That's the one that has no variable attached to it. After you identify a, b, and c, what you're going to do is you're going to now substitute those values into the quadratic formula. The quadratic formula being this formula right here. And then afterwards, you're going to just simplify it, okay? So let's look at a couple of examples together. So if you look at number 1 here, if you notice it's already in standard form. So from there, I want to identify a, b, and c. So a in this case is a number. So a in this case is the coefficient of x squared. So if you look at x squared, what's the number in front of x squared? Now, if you don't ever see a number there, that means that there's always a 1, right? So that means a is 1. And if I want to find the b value, b is just 3. That's the number in front of the x term. And then my constant c is just -4. And then from there, I would recommend everyone write down the quadratic formula. This is one of those formulas that you want to keep rewriting every single time you use it. It's going to help you memorize it much quicker, right? So keep writing it down before you actually use a quadratic formula. And then from here, what we're going to do next is we're going to plug in a, b, and c very carefully. Now, when I plug in a, b, and c, what I'm going to do is I'm going to first just put a bunch of these empty parentheses here. And the reason why I put those parentheses is because this is going to help minimize mistakes when you're making the substitution, as well as when you're simplifying. Now from here, we want to just make our substitution. So I know that a is just equal to 1. So I know that I'm going to put my a value here and my a value here. So there goes 1. And then from there, I notice that this is my b value. From there, I notice that b is just equal to 3. So that means I'm going to put 3 here, and I'm going to put 3 here. And then lastly, I notice that c is just -4, and that goes right here. And then from there, we want to simplify, right? And then we're going to simplify this by doing order of operations. So here I can just rewrite this as -3 plus or minus square root of, you want to do exponents first, right? So 3 squared is 9. And then while we're at it, I'm also going to multiply here, right? I have -4 times 1 times -4, which is positive 16, all over, and then 2 times 1 is just 2. So if you notice, I did the exponents first, and then I did the multiplication after. And then from here, we can just add, right? What is 9 plus 16? That is just 25, all over 2. And then from here, I can simplify it further because I know what the square root of 25 is, right? That's just 5. At this point, I'm going to break this up into 2 different expressions. The first one will be -3 plus 5 divided by 2. And the second one will be -3 minus 5 divided by 2. And then from here, we're going to carefully just simplify it out, right? -3 plus 5, that's just 2. 2 divided by 2 is 1. That is one of my solutions. On the right side here, negative 3 minus 5 is negative 8. And then negative 8 divided by 2 is negative 4. And this would be my final answer. So hopefully you see how we did that, right? You want to first make sure you have the equation in standard form, right? Equal to 0. And then from there, you're going to identify A, B, and C. And then once you identify A, B, and C, you're going to plug it into your quadratic formula, which I would recommend that you write this down every single time before you use it, because if you write it down enough times, you're going to memorize it much quicker. And then from there, you carefully plug everything in, right? We make our substitutions, then we simplify, and then our last step, we just solve for the two solutions. So hopefully you kind of see how we did that. If you feel ready, try number 2 on your own. And if you're not sure, you can follow along with me, okay? So at this point, I would recommend you try number 2 on your own, though. So for number 2, the first thing I'm going to do is identify A, B, and C, because it's already in that form that I want. Now, A is always a number in front of x squared, which is just the 1 here, right? So A is 1. B is a number in front of x, which in this case is just negative 4. If you notice, I didn't say it's just 4, right? But I said negative 4 because the minus in front of the 4 is part of the B value. And then the C value here is not 21, but negative 21. So I found A, I found B, I found C. And then just like I did before, I'm going to write down the quadratic formula, which is negative b plus or minus square root of b squared minus 4ac all over 2a. Now from here, I'm going to carefully plug things in, right? So for b, I can replace it with negative 4 plus or minus square root of, instead of b squared, it would be negative 4 squared. We're just substituting here. Minus 4. A is just 1, and C is just negative 21. So again, anytime I substitute, I like to always put parentheses. It's a good rule of thumb. A here is just 1. Now from here, we're going to simplify, right? I have negative 4, which if you remember, it's just positive 4, plus or minus square root of, here I have negative 4 squared, which is 16. And then here I have plus 84. And the reason why I got plus 84 is because a negative 4 times a positive 1 times a negative 21 is just a positive number in the end. On the bottom, 2 times 1 is just 2. From here, you would just combine what's inside the square root, right? 16 plus 84 is 100. And the nice thing is, I know what square root of 100 is. That would just be 10. And then from here, we can do what we did before, where we can write this as 4 plus 10 over 2, or 4 minus 10 over 2, right? Just break it into two different expressions, and then just simplify each one carefully. 4 plus 10 is 14. 14 divided by 2 is 7. On the right-hand side, 4 minus 10 is negative 6. Negative 6 divided by 2 is negative 3. And if you got 7 and negative 3, good job. If you made any mistakes along the way, not a big deal. Just learn from them moving forward, okay? But this is how we're going to be using the quadratic formula. We're going to look at a couple of examples now where they tend to get a little bit more complicated, and you'll see what I mean. So let's look at number 3 here. Don't write this down, by the way. For number 3, you can totally let A equal to 2, B equal to negative 6, and C equals to negative 36. But the problem is these numbers are kind of big, right? And we can actually avoid that in this case. There's something we can do to make the numbers a lot smaller. And this doesn't work all the time, so you should always check if you can. But see if there is a GCF, right? This is what we did when we factored, right? We looked at all the terms, and is there a greatest common factor? Because if there is, we usually factored it out, right? Now in this case, though, what I notice is, if I look at the three terms here, right? Negative 2n squared, minus 6n minus 36, I notice that they're all divisible by 2. So what I'm going to do here is I'm going to actually divide everything by 2. And that's okay. Whatever you do to one side, you got to do to the other. And when it comes to division or multiplication, you have to do that to every single term. From here, if I simplify this, I'll get n squared minus 3n minus 18 equals, and 0 divided by 2 is 0. And what's going to happen is you're going to get an equivalent equation where you'll get the same solutions in the end. The thing is, it'll make the number so much smaller, and it'll make it easier for you to get the answer. Now from here, I'll let a equal to 1, because there's a 1 here, right? That's not written. B is negative 3, and C is negative 18. And then from there, I'm going to write down the quadratic formula. Hopefully you're writing this down as well. And then from there, we're going to make our substitutions. So for negative b, I'm going to write this as negative 3. Right? Always put parentheses when you're making substitutions. Here, instead of b, I'm going to replace it with negative 3 minus 4. A is just 1, and c is negative 18. All of that will be over 2 times a, which is just 1. And then from there, you're going to carefully simplify. So negative 3 is just positive 3. Negative 3 squared is positive 9. And then here, when you do negative 4 times 1 times negative 18, a negative times a negative is positive, and you'll end up with positive 72. From here, we're going to carefully simplify what's in all over 2. Don't forget that. From here, we're going to carefully simplify what's inside the square root, right? 9 plus 72 is 81. And then from here, we're going to simplify the square root, right? Square root of 81 is just 9. Just like we've been doing before, we're going to break this up into 2 different expressions. The first one is 3 plus 9 over 2. Second one being 3 minus 9 over 2. Carefully simplify this out. You get 12 over 2, which is just 6. On the right-hand side, you'll get negative 6 divided by 2, which is negative 3. And those are your 2 solutions. So whenever you can, always look for the GCF, because if you can divide everything out by that number, if you notice, my A, B, and C values will become a lot smaller, huh? And that's going to make life a lot easier. So always look for the greatest common factor, even when you're using the quadratic formula. It'll save time and it'll make life easier. So at this point, I want you to try number 4 on your own. As usual, think about what we just did, do your best, and when you're ready, press play. Hopefully for number 4, you notice that all 3 terms are divisible by 3. 12r squared, right? 15r minus 9. So what I can do then is just divide everything by 3. 12r squared divided by 3 is 4r squared. 15 divided by 3 is just 5, so I'm left with 5r. Negative 9 divided by 3 is minus 3. And the 0 divided by 3 is 0. From here, I would identify the a value, which is 4, the b value, which is 5, and the c value, which is negative 3. And then from there, you want to write the quadratic formula. And then from there, you should have carefully plugged everything in, right? Again, when you plug things in, I would recommend you use parentheses every single time, because if you don't, you might actually end up making mistakes. And plus, it would technically not be correct sometimes if you're missing that parentheses. So here, you notice I plugged everything in carefully. We're going to simplify, right? Negative 5 plus or minus square root of 5 squared is 25. Here I have negative 4 times negative 3, which is actually going to be positive 48. You might have to do that work on the side somewhere, all over 8. And then from here, I'll get negative 5 plus or minus 48 plus 25 is actually just 73 over 8. And if you remember our discussion on radicals a long time ago, radical 73, you can actually simplify that any further. And so this is one of those times where I would just leave the answer like this. This would be my final answer. Now, if you want, you can actually write this as negative 5 plus square root of 73 over 8. And you can write this as negative 5 minus square root of 73 over 8, because these are your 2 solutions, but you can't really simplify those either, right? And it has to do with the fact that square root of 73, you can't break that down any further, and they have nothing in common, right? There's no common factors here. And so that's why a lot of times I would just leave it like this, only when I can't simplify it, right? But you always need to try to simplify it before you just stop there. So keep that in mind. Let's look at 2 more examples and then we're done. Now, if you look at number 5 here, it's a little bit different because the first thing you should notice is there's not a 0 on the other side. I need to have a 0 on one side. So what we're going to do is we're going to subtract both sides by 42. Okay. Now, if I subtract both sides by 42, I'll get 18n squared plus 10n minus 42 equals 0. If you notice, you cannot combine the 10n minus 42, right? Because they're not like terms. So just leave it as 10n minus 42. And then from here, I would divide everything by 2. The reason why is because I noticed that the greatest common factor is 2. And again, this will make life so much easier when you use the quadratic formula, so always look for this. From there, if I simplify it, I'll get 9n squared plus 5n minus 21 equals 0. And then from there, I get a equals to 9, b equals to 5, c equals to negative 21. And then what we're going to do next is we're going to write down the quadratic formula, which is negative b plus or minus square root of b squared minus 4ac all over 2a. And then we're going to carefully make our substitutions. A is 9, and C is negative 21. And if you do that carefully, you should get something like this. Now we're going to simplify. So here would be negative 5 plus or minus square root of 5 squared is 25. Now here the numbers get kind of big, right? Negative 4 times 9 times negative 21. I'm going to show you how you can multiply these out when they start getting kind of big, right? You have negative 4 times 9 times negative 21. I always first just choose two of the numbers. So for example, let me just do these two numbers and multiply that first. So negative 4 times 9 is negative 36. Negative 36 times negative 21. And then from there, what you can do is just do 36 times 21. Right? And you'll end up with 756. And it'll be positive because both numbers that are multiplied are negative, right? A negative times a negative is positive. So this will just become plus 756 all over 18. And then from here, we're just going to carefully simplify. So if I simplify this out, I'll get negative 5 plus or minus square root of, now 25 plus 756 is actually 781 all over 18. Now from here, I cannot simplify 781 any further, so I will just leave my final answer like this. So if you notice, we just had an extra step here where I have to subtract everything by 42 because if you notice, this problem required an extra step where I had to subtract 42 from both sides because again, you always want to have the 0 here, right? It's so important. And then from there, you can identify your A, B, and C. So at this point, try number 6 on your own. As usual, pause the video, and when you're ready, press play. So for this one, you should first notice that there is not a 0 on the other side. So I can't use a quadratic formula just yet. I need to add 2 to both sides. Now here I'll get 4n squared minus 6n plus 2 equals 0. Now from here, if you notice, all three terms are divisible by 2, right? That's my greatest common factor. So I could divide everything by the GCF, right? I'll end up with 2n squared minus 3n plus 1 equals 0. Then from there, I can identify the A, B, and C. Here A is 2, B is negative 3, C is 1. Now when I solve for n, I should write n equals negative b plus or minus square root of b squared minus 4ac over 2a. Technically, when I use the quadratic formula for number 5, instead of writing x equals, it should have been n equals, right? So normally you want to use the correct variable as well, depending on what the variable is being used in the problem. Now from here, we're going to carefully make our substitutions, right? Negative b is what? Negative 3 plus or minus square root of negative 3 squared minus 4 times a times c all over 2 times a. And then from here, we would carefully simplify this out. Minus 3 is just positive 3 plus or minus square root of negative 3 squared is 9 minus 8 all over 4. Here, I'll go write this as 3 plus or minus square root of 1 over 4, which is really just 3 plus or minus 1 over 4, right? Because square root of 1 is just 1. From here, I would just break this up into two expressions, right? My first one being 3 plus 1 over 4. The other one being 3 minus 1 over 4. 3 plus 1 is just 4, right? So 4 divided by 4 is 1. Here, 3 minus 1 is 2. 2 divided by 4 is just 1/2. Make sure you always reduce your fractions as well. So guys, this is pretty much it for quadratic formulas, right? Make sure you be very careful when you're plugging the values a, b, and c into your formula. Again, the formula is a little bit long, so the best way to memorize this is write this down every single time you decide to use a quadratic formula, okay? And understand that we're using this formula to solve equations of this form where everything is on one side and it's in standard form, and you have a 0 on the other side, okay? And this is the method that we can use to find the solutions. So guys, review your notes, please. Work on the homework. If you have any questions, let me know. That's it for today's lesson. I hope you guys have a wonderful rest of your day.